In example 6, we have 12 over x plus 11 minus 11x over x squared minus 121. Now, in order to subtract these rational expressions, they have to have the same denominator. And what I like to do is rewrite the problem so that the denominators are completely factored. So that would be 12 over x plus 11. Well, x plus 11 doesn't factor, so you leave it just like it is. But when we get to 11x over x squared minus 121, that binomial right there is a difference of squares. So I could write that denominator as x plus 11 and x minus 11. Now notice, these are the same exact expressions. The only thing that's different is that this denominator right here could factor. So I factored it. Okay, and x plus 11 times x minus 11 is that same thing if I multiply it out as x squared minus 121. Now, since I factored my denominators, that LCD is a lot easier to see what it is. So what's the LCD? Well, right here I have an x plus 11, a factor of x plus 11, so I'm going to write that down. And then when I get to the second expression, I have another x plus 11, but I already wrote that down, so I'm not going to write it down again. And then I have an x minus 11. So I'll write that x minus 11 down and see if I say x plus 11 times x minus 11, that covers everything in my denominators. So now I want to write the expressions, both expressions, so that they both have a denominator of x plus 11 and x minus 11. So this first one has a denominator of x plus 11 already, so all I need to multiply it is by x minus 11 in the top and in the bottom. So let's see what we get. In the numerator, I get 12x minus 132. And then for that denominator, I have to FOIL these two binomials. Well, I mean, you can FOIL it, but our least common denominator is x plus 11 and x minus 11. So you can leave it like that for right now. Minus. Okay, so what we're doing, we're making sure that both of these expressions have that denominator of x plus 11, x minus 11. And well, 11x over originally x squared minus 121, well, that's already x plus 11 and x minus 11. So I don't have to multiply this one by anything. So now I can write these two expressions as one. Since they have the same denominator, write that denominator out, x plus 11, x minus 11. And write everything up top, 12x minus 132 minus 11x. So now I just want to simplify it down one step further. And in that numerator, the 12x and the 11x are like terms. So if it's a positive 12 and a negative 11, that will give me just a positive x minus 132 over, I'm going to write it as the FOILed version of x plus 11 and x minus 11. And if I FOIL that out, remember this was a difference of squares, it would be just x squared minus 121. And that would be our final answer. In example number 6, I told you that I like to rewrite the problem if I can factor the denominator. But if you look at these two denominators, x minus 7 and x minus 3, those two binomials do not factor. So I'm going to go ahead and start off by writing the LCD. And our least common denominator would be an x minus 7, and then we would multiply that by an x minus 3. Those are the factors that we see. So we want to make both of these expressions have a denominator of x minus 7 and x minus 3. Well, in order to do that with this first expression, our denominator was x minus 7. So in order to make that x minus 7 times x minus 3, you would need to multiply it by x minus 3. And what you do to the bottom, you have to do to the top. Okay. If we look at our second expression, we already have a denominator of x minus 3. So we would want to multiply this one by x minus 7, and what you do to the bottom, you must do to the top. So let's multiply all of this out. In that numerator, we have 5x times x, which is going to give us 5x squared. Then we have 5x times negative 3, so negative 15x. In that second expression, we have 4x times x, so that's going to be 4x squared. And we have 4x times negative 7, so that's negative 28x. So moving right along, I'm going to write these two separate expressions as one expression of the same denominator. So since they already have the same denominator, I'm going to just write that as x minus 7 times x minus 3. And now I'm going to write these numerators. So we have 5x squared minus 15x minus, I'm going to put that second binomial in parentheses, 4x squared minus 28x. I put it in parentheses because we had to subtract that binomial. I think it's easier if we put it in parentheses for us to get our sign correct. So let's clear those parentheses in that numerator. Again, our denominator is x minus 7 and x minus 3. But in that numerator, if we clear the parentheses, we would have negative 4x squared and positive 28x. So let's combine our like terms. 5x squared and a negative 4x squared gives us just a positive x squared. And then if we look at our 28 and our 15 and combine those, we would get 13x. In our denominator, I would want to write that least common denominator just as it is. X minus 3 and x minus 7. I could FOIL that out, but there's really no need to. We can leave it just like this. So in example number 8, I want to start off, we're starting off by finding our least common denominator, but that's much easier if we rewrite our expressions so that the denominators are factored. So if I want to look at this trinomial in that first expression's denominator, the factors of a 6 that add to give me a -5 are -3 and -2. And then if I look at that second expression, x minus 2 does not factor. So we can easily say that our LCD is x minus 3 times x minus 2. So now I want to make sure that both of my denominators are x minus 3 and x minus 2. So in this first expression, our denominator is already x minus 3 and x minus 2, so I don't have to multiply it by anything. That 7 just comes right down. That expression did not change at all. But if I look in this second expression, our denominator was originally just x minus 2, so if I want it to be x minus 3 times x minus 2, I have to multiply that thing by x minus 3, and what I do in the bottom, I must do to the top. So the numerator becomes 9 times x minus 3, which is 9x minus 27. So now I want to write these two separate expressions as one expression, since they have the same denominator. It will be 7 plus 9x minus 27. And now I can just combine like terms in that numerator. So that would be 9x minus 20 all over x minus 3 times x minus 2. And that would be our final answer. In example number 9, to combine these two rational expressions by adding, we want to make sure that they have the same denominator. So we start off by finding the LCD, and I think that it's easiest to find the LCD if we factor those denominators and rewrite it. So I would rewrite this first expression as x over 10 divided by, now this trinomial right here, the factors of -5 that add to give me a -4 would be -5 and +1. In the second expression, if I look at that trinomial, the factors of a -7 that add to give me a -6 would be -7 and +1. So my least common denominator is x minus 5, and then I write down x plus 1, and then I can write down an x minus 7, but I already wrote down x plus 1, so I don't need to write it down again. So I want to make these expressions have denominators of x minus 5 times x plus 1 times x minus 7. So in that first expression, our denominator was x minus 5 times x plus 1. It's missing an x minus 7. So we would multiply that by the numerator and denominator. Let's go ahead and do that. Let's see. We get, okay, if I FOIL the two numerators, I would get x squared, And then I would say x times negative 7 is negative 7x, and then 10 times x is positive 10x. So negative 7 and positive 10 is just 3x. And then I would say 10 times negative 7 is negative 70. I'm going to leave the bottom written as x minus 5, x plus 1, and x minus 7. Now in the second expression, I have an x minus 7 and an x plus 1 in the denominator. The only thing it's missing is an x minus 5, so I multiply that by the top and the bottom. And I'm just going to FOIL those two top binomials. X times x is x squared. X times negative 5 is negative 5x, but 3 times x is 3x. So that would give me a negative 2x, and then 3 times negative 5 is negative 15. So what I can do now is write, since those numerators are FOILed out, I can write these two different expressions as one expression because they have the same denominator. So the denominator would be x minus 5 times x plus 1 times x minus 7. And the numerator would be x squared plus 3x minus 70 plus x squared minus 2x minus 15. And for the final answer, all we would need to do is combine our like terms in the numerator. So let's go ahead and write that denominator down again. So x squared plus x squared is 2x squared. 3x minus 2x is just x. And then negative 70 and negative 15 combine to give me negative 85. And that would be our final answer.